theorem of perpendicular axis. It is very important theorem as a examination. Okay, very important theorem. Theorem of perpendicular axis. Theorem of perpendicular axis. Theorem of perpendicular axis. Very important. It states that it states that the moment of inertia of a plane, the moment of inertia of a plane lamina of a plane lamina about an axis perpendicular to the plane of the lamina is equal to the sum of the moment of inertia of the lamina about the two axes at right angles to each other. Okay? In its own plane intersecting each other at the point where the perpendicular axis passes through it. Perpendicular axis passes through it. Okay? Theorem of perpendicular axis. It states that the moment of inertia of a plane lamina about an axis perpendicular to the plane of the lamina is equal to the sum of the moment of inertia of the lamina about the two axes at right angle to each other in its own plane intersecting each other at the point where the perpendicular axis passes through it. Okay? To put the above mathematical form, let Ix and Iy be the moment of inertia about the two axes perpendicular to each other in the plane of the lamina. Then the moment of inertia I about a line passes through the point of intersecting and perpendicular to its plane is given by I equal to Ix plus Iy. That is, to put To put the above in mathematical form, let Ix and Iy be the moment of inertia about the two axes perpendicular to each other in the plane of the lamina. Then the moment of inertia I about a line passing through the point of intersecting and perpendicular to each other, perpendicular to its plane is given by I equal to Ix plus Iy. Okay? Let OX and OY be the two perpendicular axes in plane of the lamina. Okay? Let OX and OY be the two perpendicular axes in the plane of the lamina. Let M1 be the mass of particle distance R1. Okay? Let M1 is the mass. M1 is the mass be the mass of a particle distance R1. Particle distance R1 from an axis through O perpendicular to the plane. Through O perpendicular to the plane. Perpendicular to the plane XOY. Okay? The distance of this particle from the y-axis, the distance of the particle from the y-axis is x1 and that from the x-axis is y1. Okay? Let OX and OY be the two perpendicular axes. OX and OY. Let OX and OY be the two perpendicular axes in the plane of the lamina. Let M1 be the mass of a particle distance R1 from the axis through O perpendicular to the plane XOY. The distance of this particle from the y-axis is x1 and that from the x-axis is y1. Okay? X-axis is y1. Okay? Moment of inertia of this particle about the x-axis. Moment of inertia of this particle about the x-axis. The x-axis equal to m1 y1 square. And moment of inertia of this particle about the y-axis and moment of inertia of the particle of this particle about y-axis equal to m1 x1 square. Okay? If we divide the whole lamina into a number of particles of moment of m1, m2, m3, etc. and distance r1, r2, r3, etc. So so that the corresponding distance y1, y2, y3 from the x-axis and x1, x2, x3 from the y-axis. Then moment of inertia. Moment of inertia lamina about x-axis. If we divide the whole lamina, if we divide the whole lamina into a number of particles, into a number of particles of masses m1, m2, m3 at distance etc at distance 1 minute at distance r1, r2, r3 etc, so that corresponding distance are y1, y2, y3 from the x-axis and x1, x2, x3 from the y-axis. Then moment of inertia. Moment of inertia about moment of inertia of the lamina. Moment of inertia of the lamina about x-axis equal to Ix equal to m1 y1 square plus m2 y2 square plus arrow equal to sigma m y square, okay. And moment of inertia of the lamina about y-axis, and moment of inertia of the lamina moment of inertia of the lamina about the y-axis, Iy equal to m1 x1 square plus m2 x2 square plus equal to sigma mx square, okay. Then moment of inertia of the lamina about the perpendicular axis through O, and moment of inertia of the lamina about of perpendicular axis through or perpendicular axis through O. I equal to m1 r1 square plus m2 r2 square plus equal to sigma mr square, okay, equal to m1 x1 square plus y1 square plus m2 x2 square plus y2 square plus okay. That is m1 x1 square plus m2 x2 square plus plus m1 y1 square plus m2 y2 square plus that is sigma mx square plus sigma my square, that is Ix plus I y. This is proof. This is proved. Okay. Thank you. Next theorem is theorem of parallel axis. Theorem of parallel axis. Okay.